Hello students, you are welcome to Prepclass Tutors, and with you is Mr. Chima, your Prepclass tutor on chemistry. So students, what's happening? What's going on? How have you been seeing our previous videos? Hope they have been very entertaining, engaging. Hope they have been able to help you see how or understand better how WAEC questions are being asked, and those ones that you have been finding difficult to solve. Hope our videos have really been helpful in helping you to tackle all those questions. Okay, so first and foremost, always remember to like. First of all, subscribe on our YouTube channel, like our videos, and always try to drop your comments on our comment section box so that we will be able to know how you've been faring and also be able to understand how you all know your feelings about our videos and if they have actually been very helpful in tackling all these questions that you may find challenging. So today I will be engaging you guys with questions number 31 to 35 of WAEC Chemistry Year 2020. So quickly, let us move. Question number 31. What volume of oxygen at STP is required to burn completely 7.5 dm cube of methane according to the following equation? Now this is pure stoichiochemistry, mole concept. So they're asking you the volume of oxygen at STP, standard temperature and pressure, that is required to completely burn 7.5 dm cube of methane. Now look at the way you approach such a question. Now the first thing you have to do is to rewrite this balanced equation. If it is not balanced, you have to balance it. So if you see here, they've actually helped you to balance the equation. They've made your job easier by balancing the equation. Now, from the balanced equation, write the mole ratio. Write the mole ratio from the balanced equation. So you can see here CH for methane is 1 mole, oxygen O2 is 2 moles, carbon dioxide is 1 mole, and water is 2 moles. So that means that 1 mole of methane is burned completely by 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Now, you must note that there is what we call molar volume of a gas. Now, the molar volume of a gas at standard temperature and pressure is 22.4 dm cube. It's a constant. It's a constant. So, this 22.4 dm cube is the molar volume of every gas at standard temperature and pressure. The molar volume of every gas is 22.4 dm cube. So molar volume of a gas, the formula is molar volume of a gas equals volume all over number of moles. Volume all over number of moles. So for methane, this 22.4 dm cube, which is its molar volume, equals the volume of methane divided by number of moles. So what I'm trying to do here is to look for, because since this volume of methane has been given, you use this molar volume of a gas that is constant to derive the number of moles of methane. After getting the number of moles of methane, use this mole ratio to relate it and get the number of moles of oxygen. After getting the number of moles of oxygen, you can now get the volume of oxygen. It's that simple. You understand? So first thing, get the number of moles of methane that reacted, which is molar volume of a gas, so 2.4 equals volume all over number of moles. So collect like cross multiply here, you have 22.4 n equals what? 7.5. Divide both sides by 22.4, you have your n to become 7.5 divided by 22.4, and your n becomes 0.335 moles. So now this is the number of moles of methane that was combusted by oxygen. I believe you understand. So now from the equation of reaction, 1 mole of methane needed 2 moles of oxygen for complete combustion. Let me show you back the equation of reaction. Look at the equation of reaction here. you can see that 1 mole of methane needed 2 moles of oxygen gas for complete combustion to carbon dioxide and water. So that means that the mole ratio between methane and oxygen is 1:2. Every 1 mole of methane, it will require 2 moles of oxygen for complete combustion. That will be very helpful here. Do you understand? It will be very helpful here. So now, from the equation of reaction, like we said, that 1 mole of methane needed 2 moles of oxygen for complete combustion. So therefore, the actual number of moles of oxygen becomes 2 times 0.35, because this is the actual number of moles of methane. So since 1 mole of methane requires 2 moles of oxygen for complete combustion, just multiply that number of moles of oxygen, rather that number of moles of methane by 2. So that gives you 2 times 0.335, and that gives you 0.67. So the number of moles of oxygen that's reacted or that needs to combust methane is 0.67. Very simple. So now let's now look for the volume of what? Oxygen. So from the formula of molar volume, which is molar volume is volume over number of moles. So 22.4, which is the normal volume of every gas, equals volume all over number of moles. Number of moles is 0.67. So cross multiply here, you have your volume to become 22.4 times 0.67. So your volume becomes 15.08 dmq. So which is actually 15, or you can say 15.0 dmq. Very, very simple. So this is your correct answer, 15.0 dmq. I believe you understand how we solved this question. We first of all wrote the equation of reaction to get our mole ratio. We now look for the number of moles of the volume of the reactant that was given, which is methane, to get what? Its number of what? Moles, which is 0.35. Using the equation of reaction, we related that to get the number of moles of the second reactant, which is oxygen, and that is 0.67. Then using that same formula, blah blah blah, we got our 15.0 dmq as our answer. Question number 32. When 250 centimeter cube of saturated solution of CuSO4 at 30 degrees Celsius was evaporated to dryness, 5.0 gram of the salt was obtained. What is the solubility of the salt at 30 degrees Celsius? Now, you must know one thing, that solubility questions are usually very, very tricky, and sometimes it can be crazy. But I've been able to derive one simple formula that it will be very easy for any student to apply. Now, I said that for any question on solubility, just use the formula N is CV over 1000. Using this magical formula, I tell you, no matter how rubbish the question will be, just apply this magical formula, boom, and your answer will just appear. So just use N equals CV over 1000. N represents number of moles of the words, the substance. That is being right, that is that solubility or whatever the substance is. We don't care. What you just know that this N is the number of moles of the substance. So I say here where N is the number of moles of the substance. From our formula, number of moles is mass over molar mass. So remember that molar mass of the substance is mass over number of moles. So molar mass, capital letter M, is small letter m, mass over number of moles. So when you make N the subject of formula, your number of moles becomes mass over molar mass. So in this N is called CV over 1000. This your N, number of moles, is given as mass over, I made a typo here, sorry. This small n you see here is supposed to be m, small letter m. It's supposed to be small letter m. So number of moles n is small letter m over capital letter M. Where small letter m, don't ignore this n, it's supposed to be m. There's a typo. Small letter m, which is mass all over molar mass. Mass all over molar mass. Now your C here is your concentration. Concentration is concentration in mole per dmq. That concentration is your solubility. So take this C as your solubility. Maybe you can write N is SV over 1000 if that is the way you understand it. But just know that this C here is concentration, and it is actually the solubility, or it represents the solubility of that substance at that particular temperature. V is the volume of the substance. Now, The volume of the substance is usually given in centimeter cube, so you have to convert it to dm cube. That is why this 1000 appeared here. Are you following? If the volume of the compound is given in dm cube, just use n is equals to cv to get your answer. But because the volume is given in cm cube, you have to convert cm cube to dm cube. That is why I said I brought about this 1000. So n is cv over 1000, where the volume is in cm cube. Where the volume is in cm cube. Take note of that. If the volume is not in cm cube, use n is equals to cv. All right, let's continue. So now solution. So now molar mass of, because small letter n is equals to molar mass, mass over molar mass, m over capital letter M. You have to first of all find this big M. They have given you this small m, 5 gram. You have to find this big M of the CuSO4. So molar mass of, which is the big M of CuSO4, becomes Cu is 64. They didn't even give us this. I was the one that brought this out. It's important. So Cu is 64 plus S is what? 32 plus oxygen is 16. So you have to multiply 16 by this 4. That becomes 16 times 4, and that is 64. So multiply before you add. So 64 plus 32 plus 64, because 16 times 4 is 64, will give you 160. So the molar mass, capital letter M, is 160. So from your small, now instead of using n equals cv over 1000, we are going to be using small letter m equals capital letter M equals cv over 1000. All right. So what is your small letter m? 5 all over. What's your capital letter M? 160 equals c times, what is your volume? 250 is in the question, all over 1000, because this is in centimeter cube. So cross multiply, you have c times 250 times 160. C times 250 times 160 equals 5 times 1000. 5 times 1000. So if you multiply 250 by 160, you are going to get I believe you are going to get 40,000. You multiply 250 by 160, you get 40,000. And of course 5 times 1000 is 5,000. So what you have to do is to multiply, then divide both sides. It's very simple, simple arithmetic. Multiply and divide both sides. 250 times 160 is 40,000. 5 times 1000 is 5,000. Divide both sides by 40,000. Do you understand? Divide both sides by 40,000. So that's 5,000 divided by 40,000. And that will give you 0.125 mole per dm. So this is the solubility. Very simple. Do not forget this magical formula. Do not forget this magical formula. N equals CV over 1000. Any solubility question, and boom, your answer will just what? Appear. All right. Question. So our answer is option B. Sorry, our answer is option B. 0.125 mole per dm. Question number 33. The bond between NH3 and H plus in NH4 plus is dative, covalent, hydrogen, electrovalent. Now, the reaction between ammonia and hydrogen ion is a dative covalent bond. In that kind of bond, one of the, in covalent bonding, if you remember, it involves sharing of electron. There are two types: ordinary covalent and dative covalent, or coordinate covalent. In ordinary covalent, the two stuffs that are combining together will contribute electron that is to be shared. Do you understand? But in dative or coordinate covalent, one will bring all the electrons, the other one will just come and join it. And that other one that is joining this one will not have any electron. So it's usually an ion. So hydrogen has lost its only electron, its atomos shell, to form hydrogen ion. So that hydrogen ion will combine dative covalently with ammonia to give ammonium ion. We call this one lone. Lone pair. It's the only one that has the electron to be shared. This one has no electron. Are you following? We call that kind of covalent bonding dative covalent bond. So the answer is dative covalent bond. Question number 34. Which of the following oxides has a giant covalent structure? Which of the following oxides has a giant covalent structure? Now, if you look at all this one is electrovalent combination or bonding. This one is electrovalent, but these two are covalent. But there are two compounds in group 4, or two elements in group 4 of the periodic table, silicon and carbon. They usually form giant covalent molecules. You can see here I said elements in group 4 of the periodic table like carbon and silicon usually form complex covalent and giant covalent molecules, as seen in large organic molecules like starch, that's for carbon, and silicon molecules like monosilane and disilane. Now, the group 4 elements, especially carbon and silicon, usually form giant molecules. Are you following? So because of that, the correct option is the oxide of silicon. It will be the only one that will have a giant covalent structure. So the correct answer is what? Option D. Question number 35 and the last for today. Which of the following hydroxide is not readily soluble in water? Which of the following hydroxide is not readily soluble in water? You must understand that all these hydroxide listed here, they are soluble in water, but one is not very soluble. One of them is not very soluble, but the remaining 3 are soluble. Now I said here, hydroxides that are very soluble in water are those of sodium, potassium, and ammonium. So these three given here, the first one is ammonium hydroxide. The option C is sodium hydroxide. The option D is potassium hydroxide. So those 3, potassium, sodium, and ammonium hydroxides, are very soluble in water. But calcium hydroxide is soluble in water, but not very soluble like the 3. So calcium hydroxide is soluble, but not very soluble like sodium, potassium, and ammonium hydroxide. So the correct option is calcium hydroxide, CaOH(2). It is the only hydroxide among these 3 that is not very soluble. You must note that all hydroxides that are soluble in water are known as alkalis. So an alkalis is a hydroxide that is soluble in water. Alright, so the correct option here is calcium hydroxide, option B. So students, that is the end of today's section in our WAEC 2020 past question on chemistry. You can see here I have a link here. Try joining our WhatsApp group via this link here. When you do so, you will always be updated on current educational and entertaining videos on our YouTube channel that you will be very much interested in partaking in. So till we meet again, my name still remains Mr. Chima, your Prepclass tutor on chemistry. Bye and stay safe.